Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Understanding Business 2024, Chapter 9, narrated by Omar Mohsen Ibrahim Fouad. Page 223, Chapter 9, Production and Operations Management. Learning Objectives. After you have read and studied this chapter, you should be able to describe the current state of U.S. manufacturing and what manufacturers have done to become more competitive. Describe the evolution from production to operations management. Identify various production processes and describe techniques that improve productivity, including computer-aided design and manufacturing, flexible manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. Describe operations management planning issues, including facility location, facility layout, materials requirement, planning, purchasing, just-in-time inventory control, and quality control. Explain the use of PERT and Gantt charts to control manufacturing processes. Page 224. Getting to know Shahid Khan, CEO of Flex and Gate. At just 16 years old, Shahid Khan moved to Champaign, Illinois, ready to live what he considered the American dream. However, the young Pakistani immigrant quickly lost his confidence when he discovered an enormous blizzard had hit his new Midwestern home. To make matters worse, the dorms at the University of Illinois hadn't opened yet, forcing Khan to pay $3 for a room and a meal at the local YMCA. With precious little money to his name, he began to worry about how he would survive the next 4 years at college. But his fears disappeared the next morning when he discovered a notice for a dishwashing job in the YMCA kitchen, with a starting salary of $1.20 per hour. Khan was shocked that he could recoup his losses from the previous night so quickly. "It's like, wow," said Khan, "if you put the $1.20 per hour in terms of Pakistan, you're making more than 99% of the people over there. I'm breathing oxygen for the first time." Khan channeled this enthusiasm into his work both at school and beyond. After graduating with a degree in engineering, he took a job overseeing production for a local aftermarket auto parts business named Flex and Gate. At first, Khan couldn't believe the inefficient manufacturing methods the company used to make its bumpers. In some instances, employees welded as many as 15 different parts together to make one bumper. Employing his engineering expertise, Khan gradually refined the process to make it less complicated. His hard work paid off in the form of a revolutionary new product, a bumper stamped from a single piece of steel that managed to slim down the rear end of a truck. After 7 years in the market business, though, Khan realized that the value-focused industry didn't provide much room for innovation. If If he wanted his product to succeed, he knew he had to sell directly to automakers. So, in 1978, Khan started his own company, armed with little more than a P.O. box and a small business loan. Within 2 years, he earned enough money to buy Flex and Gate from his old boss, giving him additional revenue streams as well as an established brand name. While business boomed at first, sales eventually ground to a halt when Khan's biggest client, General Motors, gave his bumper design to its large-scale suppliers. Other entrepreneurs would have reacted with anger to such a slight, but Khan kept on the bright side. It really was the right thing for them, said Khan. We had no business going from making 200 bumpers a day to making 40,000. Plus, his dealings with GM put him in contact with executives at Isuzu, one of Japan's biggest auto companies. So Khan traveled to Japan in the early 1980s in a last-ditch effort to win clients. His timing couldn't have been better. Japanese car companies had been preparing to enter the American market, but required more domestic suppliers to fuel their growth. Khan fit this need perfectly thanks to his manufacturing experience and his game-changing bumper design. Soon, Flex and Gate was manufacturing parts for Toyota, Isuzu, and Mazda. As these brands grew into some of the biggest names on the American market, Khan's company grew right along with them. By 2011, 2/3 of cars and trucks sold in America used Flex and Gate parts. And since Khan is the sole shareholder, all profits from the company's sales go to him. He's now worth more than $12.1 billion. In 2012, he used some of that immense wealth to purchase the Jacksonville Jaguars, fulfilling a personal dream to own an NFL franchise. In 2013, he purchased London soccer club Fulham. Although the Jaguars haven't exactly been Super Bowl contenders in recent years, and Fulham has had ups and downs in the English Premier League, Khan is confident that someday his teams will become another one of his comeback stories. In 2019, Khan launched All Elite Professional Wrestling with his son Tony. By setting Flex and Gate on the path to productivity, Shahid Khan made a fortune while creating thousands of jobs. It has also earned him great respect. In the auto industry. In this chapter, you learn about how other company leaders thrive and survive in the production and operations sector. You'll also find out why the United States is generally moving from a production-based economy to a service economy. Sources: Jerry Brewer, Jaguars owner Shahid Khan proves to be the exception in more ways than one among NFL owners. The Washington Post, WashingtonPost.com, January 12, 2018. Shahid Khan, Forbes.com. Accessed March 2023. Brian Solomon, Shahid Khan, the new face of the NFL and the American dream. Forbes.com. September 5th, 2012. Gary Smits. Forbes ranks Jaguars owner Shad Khan fourth on list of wealthiest NFL owners. Florida Times Union, Jacksonville.com. April 15th, 2021. Amy Lemire, The Incredible Rags to Riches Story of Billionaire Jacksonville Jaguars owner Shahid Khan. Celebrity Net Worth, CelebrityNetWorth.com. July 4th, 2021. Shahid Khan, owner, Jaguars, Jaguars.com. Accessed March 2023. Shahid Khan, what you should know about the owner of the Jacksonville Jaguars. Florida Times Union, Jacksonville.com, January 19th, 2023. James Gilbert and Getty Images. Page 225. Name that company. Locating a facility is a big decision. This company conducted an extensive search for a new global headquarters. The CEO decided on Austin, Texas, but the company also has a large gigafactory. The CEO hopes to build the company's own town where employees can live. Name that company. Find the answer in the chapter. Manufacturing and Services in Perspective. LO 9-1. Describe the current state of U.S. manufacturing and what manufacturers have done to become more competitive. Let's begin with a brief look back at manufacturing in the United States several decades ago. In 1953, American industry reached its post-war peak as factories employed about 30% of the workforce. By 1979, nearly 20 million people worked in manufacturing. Since then, however, the number of Americans employed by factories has steadily dropped year after year. Approximately 12.5 million people worked in manufacturing in 2021. However, the value of products made in the United States continues to reach a record high. In other words, this is still a very productive time for American manufacturing. So how has output been able to increase while the number of factory workers continues to fall? Thanks to advancements in technology and automation, American factories can operate efficiently without large amounts of human labor, whereas robots have been performing manufacturing tasks for decades. Past models were so big and dangerous that people could rarely be in the same room with them. Now, many factory employees work side by side with robots that can learn from and collaborate with their human colleagues. West End 61 and Getty Images. Unlike their colossal predecessors, many modern factory robots safely work side by side with humans. Do you think that manufacturing could someday be driven entirely by automated labor? These advancements have drastically changed the types and quality of jobs available at today's factories. In the past, workers with a high school diploma could land a well-paying job on an assembly line. As technology and automation increased, though, robots began performing many repetitive tasks formerly done by workers. For some perspective on this shift to automated labor, in 1980, factories needed 25 people to produce $1 million worth of manufacturing output. Today, it takes only 6 people. Employees in these positions, however, must have advanced skills to be hired and succeed. So rather than relying on low-skill assembly line workers, modern factories depend on engineers and software developers to operate their cutting-edge equipment and technology with trained and qualified workers. Due to these changes, American industry likely will never employ as many people as it did in the 1950s through 1970s. Today's economy overwhelmingly depends on services rather than manufacturing. More than 70% of U.S. GDP is consumer spending, and almost 80% of jobs are now in the service sector. This includes professionals like lawyers, doctors, and teachers, as well as business services like accounting, finance, and management consulting. Manufacturers today must compete with companies in lucrative fields such as high technology development when recruiting top talent. Many American factories have struggled to fill positions as many engineers and computer experts migrated to the tech industry. In 2023, many large tech companies reduced their tech workforce. This could be a boost to hiring in manufacturing. Additionally, the COVID-19 pandemic, the trade war with China, and the Ukrainian war have caused many shocks and significant disruptions to supply chains in the United States and worldwide. Many government and business leaders have called for a reshoring of manufacturing back to the United States. The Reaching Beyond Our Borders box highlights the effort in the United States to bring the critical microchip industry back to the U.S. shores. Page 226. Reaching Beyond Our Borders. Chipping away at a big challenge. The COVID-19 pandemic wreaked havoc on supply chains across the globe. Producers worldwide were forced to slash manufacturing schedules with little hope of finding a quick answer to the supply crisis. The pain was felt across multiple product categories and industries. And there was a fear the world could possibly run out of semiconductor chips. These little chips are the heart of many products we depend upon, i.e., important example, cars, phones, appliances, defense weapons, etc. Without semiconductor chips, much of U.S. manufacturing could come to a standstill. The automotive sector, the second largest user of microchips behind consumer electronics, estimates it lost $210 billion due to the chip shortage. The U.S. Defense Department was concerned the advanced chips needed for its modern defense weapon system would not be available. Though little could be done in the immediate crisis, a decision was made that the United States needs to have chip production available closer to home. Vadim Zakupov and iStock and Getty Images Plus and Getty Images. The Chips of America program was established to build up semiconductor research and manufacturing in the United States. The U.S. Commerce Department was allocated $50 billion that it can make available in direct funding, federal loans, and loan guarantees to qualified companies. The largest portion of the money, $39 billion, is intended for the construction of new and expanded manufacturing facilities. $11 billion is earmarked to support research and new chip technologies. Unfortunately, even with the government's strong commitment, increasing semiconductor research and production will be a very difficult task. Semiconductor demand is difficult to predict. Estimates are that demand in the future will be driven by artificial intelligence, AI, electric and autonomous vehicles, and 5G and 6G. The problem is the exact nature, speed, and magnitude of the chips needed are unknown. The stakes are high and the challenges are significant in expanding chip production in the United States. Sources: America's Answer to the Chip Shortage, The Wall Street Journal, WSJ.com, February 23, 2023. Anna Swanson, The CHIPS Act is about more than chips. Here's what's in it. Fortune.com, February 28, 2023. Momita Deb Choudhury, U.S. sets guidelines for semiconductor makers seeking CHIPS Act funds. Computerworld.com, March 1st, 2023. Rakesh Kumar, we're going to see another chip shortage, despite the Chips and Sciences Act. Fortune.com, March 1st, 2023. Manufacturers and service organizations become more competitive. Although American industry is more productive than ever, it faces increased competition from all over the world. U.S. producers must compete with China's and Germany's mighty manufacturing firms, as well as expanding enterprises in South Korea, Vietnam, and India. Many foreign manufacturers depend on U.S. technology and concepts to increase effectiveness and efficiency. But plenty of innovation happens globally as well, meaning that American manufacturers must keep up with the latest production techniques no matter where they are developed. Service providers will also need to step up their game as the sector becomes increasingly crowded. However, improving the efficiency of services isn't as easy as it sounds. After all, would you choose a hairstylist or dentist just because they can give you the quickest service possible? Instead, companies in the service sector must focus on providing customers with quality care and attention. They also need to maintain close relationships with their suppliers and other companies in order to satisfy customer needs. Finally, like their counterparts in manufacturing, service providers must continuously improve if they want to maintain their competitive edge. Page 227. This chapter explores these and other operations management techniques in both the service and manufacturing sectors. Let's begin by going over a few key terms. From production to operations management. LO 9-2. Describe the evolution from production to operations management. Production is the creation of finished goods and services using the factors of production: land, labor, capital, entrepreneurship, and knowledge. See Chapter 1. Production has historically meant manufacturing, and the term production management has described the activities that helped firms create goods. As we discussed in the previous section, though, in recent decades, the U.S. economy has been largely driven by services rather than manufacturing. Operations management is a term that is used in both manufacturing and service organizations. Operations management is a specialized area in management that converts or transforms resources, including human resources like technical skills and innovation, into goods and services. It includes inventory management, quality control, production scheduling, follow-up services, and more. In automobile plants, such as Tesla or Ford, operations management transforms raw materials, human resources, parts, supplies, paints, tools, and other resources into automobiles. It does this through the process of fabrication and assembly. In a service-based setting like a college or university, operations management takes inputs such as information, professors, supplies, buildings, offices, and computer labs and systems, and creates services that transform students into educated people. It does this through processes like teaching and explanation. Some organizations, such as factories, farms, and mines, produce mostly goods. Others, such as hospitals, schools, and government agencies, produce mostly services. Some produce a combination of goods and services. For example, an automobile manufacturer not only makes cars, but may also provide services such as repairs, financing, and insurance. At Wendy's, you get goods such as hamburgers and fries, but you also get services such as order taking, order filling, food preparation, and cleanup. Operations management in the service sector. Operations management in the service sector is all about creating a good experience for those who use the service. In a Hilton hotel, for example, operations management includes smooth running elevators, fine restaurants, comfortable beds, and a front desk that processes people quickly. It may also include fresh cut flowers in lobbies, a heated pool, exercise facilities, bowls of fruit, and computer services in every room. Piroshka van de Woo and Reuters and Alamy stock photo. Automation allows companies to streamline simple tasks that would normally require costly human labor. This robo-server delivers plates of food to customers at an Asian fusion restaurant in the Netherlands, saving the company money on servers in the long run. Which would you rather have your food served by, a human or a robot? Page. Along with these classic amenities, Hilton must also stay innovative so it can cater to the ever-changing needs of its guests. Most business travelers today expect in-room Wi-Fi as well as updated work centers that provide all the resources of a modern office. Hilton provides these services and also develops new features that become standard in their hotels. One example is keyless room entry. Rather than give guests a key card they can easily lose, Hilton created a system that allows guests to use their smartphone to enter their room. Hilton introduced Connie, an AI-assisted robot that can answer guests' basic questions regarding entertainment options, dining reservations, and directions. Robots today are increasingly commonplace in hotels and other businesses. E-commerce giant Amazon purchased Kiva, a producer of mobile warehouse robots, and now has over 500,000 robots stationed in its warehouses. Page 228. Angie and E+, and Getty Images. Operations management for services is all about enriching the customer experience. Hotels, for instance, have responded to the needs of business travelers with in-room internet access, comfortable desks, and other kinds of office-style support. What other sort of amenities do you think hotels should provide to attract business travelers? Service businesses have significantly increased the use of artificial intelligence, AI, in their operations. For example, Hilton uses an AI-backed interview platform in its recruiting process. Food delivery service such as DoorDash use an AI delivery guide to assist drivers in the best route to take to service consumers. They also use AI models that analyze food ordering trends to measure future demand due to pricing issues and economic conditions. Management consulting firms estimate that by 2030, 70% of businesses will be using some type of AI that will change life and business operations. In short, pleasing customers by anticipating their needs has become a quality standard for companies. But knowing customer needs and satisfying them are two different things. Operations management acts as a bridge between these concepts, allowing companies to turn their ideas into actual goods and services. Next, we'll explore production processes and what companies are doing to keep the United States competitive in that area. Test prep. How has manufacturing changed in the United States over the last few decades? What must American companies do to remain competitive? How does operations management differ between the manufacturing and service sectors? Production processes. LO 9-3. Identify various production processes and describe techniques that improve productivity, including computer-aided design and manufacturing, flexible manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. Common sense and some experience have already taught you a lot about production processes. For instance, you know what it takes to write a term paper or prepare a dinner. You need money to buy the materials, you need a place to work, and you need to be organized to get the task done. The same is true of the production process in industry. It uses basic inputs to produce outputs. See Figure 9.1. Production adds value or utility to materials or processes. Page 229. Figure 9.1. The production process. The production process consists of taking the factors of production, land, etc., and using those inputs to produce goods, services, and ideas. Planning, routing, scheduling, and the other activities are the means to accomplish the objective output. Inputs: land, labor, capital, entrepreneurship, knowledge. Production control: planning, routing, scheduling, dispatching, follow-up. Outputs: goods, services, ideas. McGraw-Hill, Connect. I see it. Need help understanding the transformation process for goods and services? Click on the video for a brief animated explanation. Form utility is the value producers add to materials in the creation of finished goods and services, such as by transforming silicone into computer chips or putting services together to create a vacation package. Form utility can exist at the retail level as well. For example, a butcher can produce a specific cut of beef from a whole cow, or a baker can make a special type of cake from basic ingredients. We'll be discussing utility in more detail in Chapter 15. Manufacturers use several different processes to produce goods. Andrew S. Grove, the late former CEO and chair of computer chip manufacturer Intel, used this analogy to explain production. Imagine that you are a chef and that your task is to serve a breakfast consisting of a 3-minute soft-boiled egg, buttered toast, and coffee. Your job is to prepare and deliver the 3 items simultaneously, each of them fresh and hot. Grove says this task encompasses the 3 basic requirements of production. 1. To build and deliver products in response to the demands of the customer at a scheduled delivery time. 2. To provide an acceptable quality level. And 3. To provide everything at the lowest possible cost. Let's use the breakfast example to understand process and assembly. Process manufacturing physically or chemically changes materials. For example, boiling physically changes an egg. Similarly, process manufacturing turns sand into glass or computer chips. The assembly process puts together components, eggs, toast, and coffee, to make a product, breakfast. Cars are made through an assembly process that puts together the frame, engine, and other parts. Production processes are either continuous or intermittent. A continuous process is one in which long production runs turn out finished goods over time. A continuous process is one in which long production runs turn out finished goods over time. As a chef, you could have a conveyor belt that continuously lowers eggs into boiling water for 3 minutes and then lifts them out. A 3-minute egg would be available whenever you wanted one. Chemical plants and steel mills, for example, are run on a continuous process. Larissa Sedamutsova and Shutterstock. Bakers add form utility to materials by transforming basic ingredients like milk, flour, and sugar into special customized cakes. Can you see how the production of such cakes involves both process manufacturing and assembly processes? It usually makes more sense when responding to customer orders to use an intermittent process. Here the production run is short, 1 or 2 eggs, and the producer adjusts machines frequently to make different products, like the oven in a bakery or the toaster in a diner. Manufacturers of custom-designed furniture would use an intermittent process. Today, many more manufacturers use intermittent processes. Computers, robots, and flexible manufacturing processes allow firms to turn out custom-made goods almost as fast as mass-produced goods were once produced. We'll discuss how they do that in more detail in the next few sections as we explore advanced production techniques and technology. Page 230. The need to improve production techniques and cut costs. The ultimate goal of operations management is to provide high-quality goods and services instantaneously in response to customer demand. As we stress throughout this book, traditional organizations were simply not designed to be responsive to the customer. Rather, they were designed to make goods efficiently, quickly, and inexpensively. The idea behind mass production was to make a large number of a limited variety of products at a very low cost. Over the years, low cost often came at the expense of quality and flexibility. Furthermore, suppliers didn't always deliver when they said they would, so manufacturers had to carry large inventories of raw materials and components to keep producing. Such inefficiencies made U.S. companies vulnerable to foreign competitors who were using more advanced production techniques and less expensive labor. As a result of new global competition, companies have had to make a wide variety of high-quality custom-designed products at low cost. Clearly, something had to change on the production floor to make that possible. Fortunately, several major developments made U.S. companies more competitive. 1. Computer-aided design and manufacturing. 2. Flexible manufacturing. 3. Lean manufacturing. 4. Mass customization. 5. Robotics. And 6. 3D printing. Computer-aided design and manufacturing. One development that changed production techniques is the use of computers to design products. Called computer-aided design, CAD. Businesses ranging from construction companies to car makers to video game designers depend on 3D modeling software to create new products. The next step was to bring computers directly into the production process with computer-aided manufacturing, CAM, CAD, and CAM. The use of both computer-aided design and computer-aided manufacturing makes it possible to custom design products to meet the needs of small or specific markets with very little increase in cost. A manufacturer programs the computer to make a simple design change, and that change is readily incorporated into production. In the clothing industry, a computer program establishes a pattern and cuts the cloth automatically, even adjusting to a specific person's dimensions to create custom cut clothing at little additional cost. In food service, CAM supports on-site, small-scale, semi-automated, sensor-controlled baking and fresh-baked cookie shops to make consistent quality easy to achieve. 3D printers are among the latest CAM technology. With 3D printing, a product is made layer by layer until it appears, almost by magic, as a finished good. CAD can greatly improve productivity for businesses. In the past, CAD machines couldn't talk to CAM machines directly. Today, software programs unite CAD and CAM. The result is computer-integrated manufacturing, CIM. When companies use CIM, computers control the entire production process. The software is expensive, but it can drastically reduce the time needed to program machines to increase production. Flexible manufacturing. Flexible manufacturing means designing machines to do multiple tasks so they can produce a variety of products. Alan Bradley uses flexible manufacturing to build motor starters. Orders come in daily, and within 24 hours, the company's machines and robots manufacture, test, and package the starters, which are untouched by human hands. Allen Bradley's machines are so flexible that managers can include a special order, even a single item, in the assembly without slowing down the process. Today, Toyota and Mazda use flexible manufacturing to increase or decrease capacity without affecting production costs. If they need to change capacity, it can be done in a weekend. Marlene Awed and Bloomberg and Getty Images. Designers at this lace factory in France use 3D CAD tools to create intricate, beautiful patterns that serve as ideal guides for the production process. What advantages might this technology offer to small manufacturing companies? Page 231. Lean manufacturing. Lean manufacturing is the production of goods using less of everything than in mass production, less human effort, less manufacturing space, less investment in tools, and less engineering time to develop a new product. A company becomes lean by continuously increasing its capacity to produce high-quality goods while decreasing its need for resources. Technological improvements are largely responsible for the increase in productivity and efficiency of U.S. plants. That technology made labor more productive, but also presented other challenges. After all, employees can get frustrated by innovations, like, for example, they must learn new processes. And companies must constantly train and retrain employees to stay competitive. One way companies stay competitive is by making products that are more individualistic. The next section discusses how that happens. Mass customization. To customize means to make a unique product or provide a specific service to specific individuals. Although it once may have seemed impossible, mass customization, which means tailoring products to meet the needs of a large number of individual customers, is now practiced widely. The National Bicycle Industrial Company in Japan made 18 bicycle models in more than 2 million combinations and designed to fit the needs of a specific customer. A popular trend today involves foldable bikes made to customer specifics. London-based Brompton is the industry standard for folding bikes. It takes various measurements from the buyer and sends the data to the factory, where robots and workers handle the bulk of the assembly. More and more companies are learning to customize their products. The fashion startup Proper Cloth uses software called Smart Sizes to custom design shirts for online shoppers. Nature Made creates customized vitamin packs to suit individual needs. For those with more of a sweet tooth, you can even buy custom-made M&Ms in colors of your choice. Mass customization exists in the service sector as well. Some insurance companies use the latest computer software and hardware to sell customized risk management plans to companies. Vanguard offers personalized retirement plans to fit each individual's wants and needs. Health clubs offer unique fitness programs for individuals. Travel agencies provide vacation packages that vary according to individual choices, and some colleges allow students to design their own majors. It is much easier to custom design service programs than to custom make goods because there is no fixed tangible good to adapt. Each customer can specify what they want within the limits of the service organization, limits that seem to ever limits that seem to be ever widening. Robotics. Industrial robotics can work 24 hours a day, 7 days a week with great precision. Mass customization is no problem for them. At least, no one has heard them complain. Robots have completely changed manufacturing by improving productivity. Today, collaborative robots, cobots, work side by side with humans. They perform tasks that are repetitive or dangerous and or require precision. Along with assembly line jobs in factories, robots have begun to move into service businesses as well. It's possible that in the very near future, robots will be pervasive in airports, handling tasks such as check-in, security, and concierge services. Wall Street financial anal- Wall Street financial analysts are competing for jobs with AI-enabled robots. See Chapter 19. And a robot named IceFin is testing the ice health of glaciers in Antarctica. In other words, in many cases, robots are slowly but surely either helping workers perform better and making their jobs easier, or possibly replacing them. Robotic technology will likely take over a good deal of the production process, but humans will continue to produce value by thinking and acting creatively. The global robotics market is expected to grow to over $86 billion in 2027. The Adapting to Change box looks at what is happening right now as the use of robots grows in the workplace. Page 232. Adapting to Change. Flippy stakes its claim in the kitchen. There are few workplaces more hectic than commercial kitchens, packed full of people and roaring hot burgers. New orders fly in at a rapid pace as cooks rush to get food through the window and onto tables. In this busy environment, it's easy to forget about a burger patty as it burns on the grill, or an order of fries that become soggy sitting on the counter. That is unless you are Flippy too, an automated food service system that can flip burgers, fry fries, and cook chicken without any help from humans. Developed by the California-based startup Miso or Miso Robotics. The sophisticated machine is a vast improvement upon the first Flippy, which required employees to set burger patties on the grill so the robot could cook them. This is a case where the sequel is much better than the original. According to Miso, Flippy 2 takes over the work for an entire fry station and performs more than twice as many food preparation tasks compared to the previous version including basket filling, emptying, and returning. Courtesy of Miso Robotics. Enabled by artificial intelligence AI, Flippy 2 can identify the food it needs, pick it up, cook it, and then drop it in a basket that is placed in a heated holding area. This allows the machine to crank out 60 baskets of food per hour, amounting to about 300 burgers per day, entirely without human intervention. And in case all this sounds like science fiction, in 2022, the burger chain White Castle installed Flippy 2 in more than 100 locations across the country after the robot impressed during a pilot program. As for restaurants that continue to face labor shortages related to the pandemic, they might want to hire the dependable Flippy 2 as their new fry cook in an effort to bring much needed stability in certain times. Sources: Amrita Khalid, a burger flipping robot, may be coming to a White Castle near you. Engadget.com, February 15th, 2022. Kristen Altus, White Castle hiring robots to give the right tools for serving more hot and tasty food. Fox Business, foxbusiness.com, January 7, 2023. Stacy Liberator, Rise of the Restaurants Robots. Daily Mail, dailymail.co.uk, January 4th, 2023. 3D printing, one of the most exciting production processes to emerge in recent years, has been 3D printing. During this advanced procedure, also known as additive manufacturing, a product is created one layer at a time by a nozzle similar to those found in inkjet printers. 3D printing has grown rapidly, driven by rapid technological developments. Expectations are that 3D printing could grow to a market reaching $35 billion by 2024. Most companies use 3D printing to create prototype models or molds for other industrial projects due to their significantly reduced costs. However, 3D printing has revolutionized the production of all sorts of items. For example, General Motors' ultra-luxury Cadillac Celestiq includes over 100 3D printed parts. Adidas contracted with 3D printing company Carbon to make its 4D FWD high-end running shoe. French fashion producer Dior also used 3D printing technology for its work boots. The U.S. Department of Defense and Energy have partnered with companies such as Cincinnati Incorporated to use 3D printing to make machine tool components for a fraction of the cost of making them with traditional methods. The world's first 3D printed steel footbridge was opened in Amsterdam, the Netherlands. Today, 3D printing has been used to construct concrete footbridges, orthopedic implants, and components for aircraft. Your next home may even be a 3D printed house. Page 233. Guido Kirchner and DPA and Alamy stock photo. 3D printing isn't just for prototypes. This house in Germany was built in layers using a 3D concrete printer providing both an affordable and efficient construction option for homeowners. Can you think of any other structure that could be 3D printed? Using sensing, measurement, and process control. Most advanced manufacturing techniques are driven by computers working with vast amounts of data. Such data controls include sensors that measure humidity, global positioning trackers that fix location, or calipers that measure a material's thickness. Products can be tracked from the beginning of production to the point of delivery. The moment anything goes wrong, a sensor can detect it immediately and notify someone to make the needed changes. Companies are also using nano manufacturing. A nanometer is 1/1000th of a meter. So nano manufacturing means being able to manipulate materials on a molecular, or even atomic scale. Test prep. What is form utility? Define and differentiate the following: process manufacturing, assembly processes, continuous processes, and intermittent processes. What do you call the integration of CAD and CAM? What is customization? Operations Management Planning, LO 9-4. Describe operations management planning issues including facility location, facility layout, materials requirement planning, purchasing, just-in-time inventory control, and quality control. Operations management planning helps solve many of the problems in the service and manufacturing sectors. These include facility location, facility layout, materials requirement planning, purchasing, inventory control, and quality control. The resources used may be different, but the management issues are similar. Facility location. Facility location is the process of selecting a geographic location for a company's operations. In keeping with the need to focus on customers, one strategy is to find a site that makes it easy for consumers to use the company's services and to communicate about their needs. Flower shops and banks have placed facilities in supermarkets so that their products and services are more accessible than in freestanding facilities. Starbucks has also set up operations in supermarkets and Target stores. You can find a McDonald's inside some Walmart stores or gas stations. Page 234. Of course, the ultimate convenience is never having to leave home to get something. That's why services like online banking and online shopping are so popular. E-commerce uses Facebook and other social media to make transactions even easier. For brick and mortar retailers to beat such competition, they have to choose good locations and offer outstanding service. Large brick and mortar stores such as Walmart and Target have set up their own e-commerce operations. Study the location of service sector businesses such as hotels, banks, health clubs, hospitals, and supermarkets, and you'll see that the most successful are conveniently located. Facility location selection can be a detailed process. For example, CEO Elon Musk conducted an extensive search for a location for Tesla's new global headquarters. He selected Austin, Texas as the headquarters' new home. The company also has a large gigafactory in Austin. Musk said he intends to buy up land around the Tesla facility and develop a town for his employees to live in. Michael Wells and Getty Images. Facility location is a major decision for manufacturers and other companies. The decision involves taking into account the availability of qualified workers, access to transportation suppliers and customers, and local regulations including zoning and taxes. How has the growth of commerce on the internet affected company location decisions? Facility location for manufacturers. Geographic shifts in production sometimes result in pockets of unemployment in some geographic areas and tremendous growth in others. For instance, the decline of auto manufacturing caused the economy of Detroit to decline for many years. At the same time, the rise of the tech industry turned Silicon Valley into one of the wealthiest places in the world. Why would companies spend millions of dollars to move their facilities from one location to another? They consider labor costs, availability of resources, including labor, access to transportation that can reduce time to market, proximity to suppliers, proximity to customers, crime rates, housing stock, quality of life for employees, cost of living, and the need to train or retrain the local workforce. Even though labor is becoming a smaller percentage of total cost in highly automated industries, availability of low-cost labor or the right kind of skilled labor remained a key reason many producers have plants in Malaysia, China, India, Mexico, Vietnam, and other countries. In general, U.S. manufacturing firms tend to pay more and offer more benefits than firms elsewhere in the world. Inexpensive resources are another major reason for moving production facilities. Companies usually need water, electricity, wood, coal, and other basic resources. By moving to areas where these items are inexpensive and plentiful, firms can significantly lower not only the cost of buying such resources, but also the cost of shipping finished products. Often, the most important resource is people, so companies tend to cluster where trained, educated, and talented people are, such as Silicon Valley. Time to market is another decision-making factor. As manufacturers attempt to compete globally, they need sites that allow products to move quickly at the lowest costs so they can be delivered to customers fast. Access to highways, rail lines, waterways, and airports is thus critical. Information technology, IT, is also important to quicken response time. So many firms seek locations with the most advanced information systems. Another way to work closely with suppliers to satisfy customers' needs is to locate production facilities near supplier facilities. That cuts the cost of distribution and makes communication easier. Many businesses build factories in foreign countries to get closer to their international customers. That's a major reason the Japanese automaker Honda builds cars in Ohio and the German company Mercedes builds them in Alabama. When U.S. firms select foreign sites, they consider whether they are near airports, waterways, and highways so that raw and finished goods can move quickly and easily. Page 235. Businesses also study the quality of life for workers and managers. Are good schools nearby? Is the weather nice? Is the crime rate low? Does the local community welcome new businesses? Do the chief executive and other key managers want to live there? Sometimes a region with a high quality of life is also an expensive one, which complicates the decision. In short, facility location is a critical issue in operations management. The Making Ethical Decisions box looks at the difficult decisions companies must make when it comes to locating. Making ethical decisions, loyalty or profitability. Trust Us Industries has long been the economic foundation for its hometown. Most of the area's small businesses and schools either supply materials the firm needs for production or train its future employees. Generations of its citizens have worked at the company. Trust Us has been and still is profitable, but a business consulting firm projected that moving production facilities to Vietnam could potentially increase profits by as much as 20%. Closing operations would cause many of the town's other businesses, such as restaurants and small retail stores, to fail, leaving a high percentage of the town's adults unemployed. With limited options for new employment. As a top manager and major owner, you must decide whether the plant should be moved, and if so, when the announcement will be made. Federal law says you must inform employees at least 60 days before closing the plant. What are your relatives? What are the consequences of each? Which will you choose? Interfirm operations management. Many rapidly growing companies do very little production themselves. Instead, they outsource engineering, design, manufacturing, and other tasks to companies such as Flex, Foxconn, and Sanmina that specialize in those functions. They create new relationships with suppliers online, making operations management an inter-firm process in which companies work closely together to design, produce, and ship products to customers. Manufacturing companies are developing online strategies that will enable them and others to compete more effectively in the future. These changes are having a dramatic effect on operations managers as they adjust from a one-firm system to an inter-firm environment. So rather than a relatively stable system that companies can solely control, they must now deal with an environment that is constantly changing and evolving. Facility location in the future. Information technology, IT, that is computers, software, Wi-Fi, email, voicemail, texting, video conferencing, and so forth, is giving firms and employees increased flexibility to choose locations while staying in the competitive mainstream. Telecommuting, working from home via computer, is an expanding trend in business. Companies will no longer need to locate near sources of labor. They are able to locate in areas where land is less expensive and the quality of life may be higher. Plus, the COVID-19 pandemic proved it's never been easier to stay in touch by computer thanks to video conferencing apps like Skype, Zoom, and WebEx. Another big incentive to locate in a particular city or state is the tax situation there and degree of government support. Some states and local governments have higher taxes than others, yet many compete fiercely by offering companies tax reductions and other support, such as zoning changes and financial aid, so they will locate there. Facility layout. Facility layout is the physical arrangement of resources, including people, to most efficiently produce goods and provide services for customers. Facility layout depends greatly on the processes that are to be performed. For services like retail, the layout is usually designed to help the consumer find and buy things. Other service-oriented organizations, such as hospitals, use layouts that improve efficiency, such as manufacturers do. After all, the right facility layout can greatly reduce a factory's or hospital's cost in the long term. Page 236. Many companies are moving from an assembly line layout in which workers do only a few tasks at a time to a modular layout in which teams of workers combine to produce more complex units of the final product. There may have been a dozen or more workstations on an assembly line to complete an automobile engine in the past, but all that work might be done in one module today. Asman, Jaka, and E+, and Getty Images. This open office plan provides employees with space to collaborate at communal workstations that encourage interaction and cooperation. Do you think open office plans are an effective way to keep workers productive? When working on a major project, such as a bridge or an airplane, companies use a fixed position layout that allows workers to congregate around the product to be completed. A process layout is one in which similar equipment and functions are grouped together. The order in which the product visits a function depends on the design of the item. This allows for flexibility. Packaging manufacturer Aegis in Cologne, Germany, can shrink or expand its layout in a flash. Its flexible design keeps its packaging competitive in a fast-changing, highly competitive market. Because the layout of the plant changes often, many employees use scooters in order to more efficiently provide needed skills, supplies, and services to multiple workstations. A fast-changing plant needs a fast-moving employee base to achieve maximum productivity. Figure 9.2 illustrates typical layout designs. Figure 9.2, typical layout designs. Product layout, also called assembly line layout, used to produce large quantities of a few types of products. Process layout, frequently used in operations that serve different customers, different needs. Storage, cutting, stamping, deburring, shipping, packing, assembly, bending. Storage, cutting, stamping, deburring, cutting, assembly, deburring, bending, assembling, packaging, shipping. Cellular or module layout. can accommodate changes in design or customer demand. Saws, planing machines, drills, assembly tables, sanders, lathes. Fixed position layout. A major feature of planning is scheduled work operations. Roofing contractor, general carpentry and supplies, grading equipment and operators, architect, painting contractor, finish carpentry, plaster contractor, electrical contractor, masonry contractor, plumbing contractor. Materials Requirement Planning. Materials Requirement Planning, MRP, is a computer-based operations management system that uses sales forecasts to make sure needed parts and materials are available at the right time and place. Enterprise Resource Planning, ERP, a newer version of MRP, combines the computerized functions of all the divisions and subsidiaries of the firm, such as finance, human resources, and order fulfillment, into a single integrated software program that uses a single database. The result is shorter time between orders and payment, less staff needed to do ordering and order processing, reduced inventories, and better customer service. For example, the customer can place an order either through a customer service representative or online and immediately see when the order will be filled and how much it will cost. The representative can instantly see the customer's credit rating and order history, the company's inventory, and the shipping schedule. Everyone else in the company can see the new order as well. Thus, when one department finishes its portion, the order is automatically routed via the ERP system to the next department. The customer can see exactly where the order is at any point by logging in to the system. Purchasing. Purchasing is the function that searches for high quality material resources, finds the best suppliers, and negotiates the best price for quality goods and services. Some manufacturers purchase from many suppliers so that if one can't deliver, the firm can get materials from someone else. Others, however, develop close relationships with just a few suppliers so that they can secure affordable prices in the long term. Which strategy do you think works best, purchasing from many suppliers or just a few suppliers? The internet has also transformed the purchasing function. Businesses that once needed connections to a certain industry can now go online to find the best items at the best price. Similarly, a company wishing to sell supplies can use the internet to find all the companies looking for such supplies. The time and dollar cost of purchasing items have thus been reduced tremendously. Page 237. Just-in-time inventory control. One major cost of production is the expense of holding parts. Motors, and other items in storage for later use. Storage not only subjects items to obsolescence, theft, and damage, but could also require construction and maintenance of costly warehouses. To cut such costs, many companies have implemented a concept called just-in-time (JIT) inventory control. JIT systems keep a minimum of inventory on the premises and deliver parts, supplies, and other needs just in time to go on the assembly line. To work effectively, however, the process requires an accurate production schedule using ERP, and excellent coordination with carefully selected suppliers who are connected electronically so they know what will be needed and when. Sometimes these suppliers build new facilities close to the main producer to minimize distribution time. JIT runs into problems such as weather delays, like for example, typhoon, hurricane. When suppliers are farther away, the COVID-19 pandemic caused major issues that caused many companies to evaluate whether to maintain a JIT system or revert back to previous inventory control methods. Still, when all the right pieces are in place, JIT systems make sure the right materials are at the right place at the right time at the cheapest cost to meet both customer and production needs. That's a key step in maintaining modern production innovation. Page 238. Quality control. Maintaining quality means consistently producing what the maintaining quality means consistently producing what the customer wants while reducing errors before and after delivery. In the past, firms often conducted quality control at the end of the production line. Products were completed first and then tested for quality. This resulted in several problems. 1. The need to inspect work required extra people and resources. 2. If an error was found, someone had to correct the mistake or scrap the product. This, of course, was costly. 3. If the customer found the mistake, they might be dissatisfied and even buy from another firm thereafter. Such problems led to the realization that quality is not an outcome. It is a never-ending process of continually improving what a company produces. Quality control should thus be part of the operations management planning process rather than simply an end-of-the-line inspection. Nestle Purina was awarded a Baldrige. What's that? It's like Best in Show, but for business. Malcolm Baldrige, National Quality Award 2010 award recipient. Nestle Purina Pet Care Company wishes to thank our associates, customers, and business partners for helping us be our best. We are honored to be the first consumer packaged goods company to receive the Malcolm Bridge National Quality Award for Organizational Performance Excellence and share our success with the community. www.purina.com, www.nestlepurinacareers.com. Purina, your pet, our passion. Nestle Purina Pet Care Company. Nestle Purina Pet Care, a company headquartered in St. Louis, received the Malcolm Baldrige National Quality Award in the manufacturing category. What quality criteria do you think the award was based on? Companies have turned to the use of quality control standards such as Six Sigma quality, which sets a benchmark of just 3.4 defects per million opportunities, detects potential problems to prevent their occurrence. That's important to a company that makes 4 million transactions a day. Like some banks, Statistical Quality Control, SQC, is the process some managers use to continually monitor all phases of the production process and ensure quality is being built into the product from the beginning. Statistical process control, SPC, is the process of testing statistical samples of product components at each stage of production and plotting the test results on a graph. Managers can thus see and correct any deviation from quality standards, making sure products meet standards all along the production process, reduces the need for a quality control inspection at the end because mistakes are caught much earlier in the process. SQC and SPC thus save companies much time and money. Some companies use a quality control approach called the Deming cycle, after the late W. Edwards Deming, the father of the movement toward quality. Its steps are plan, do, check, act, PDCA. Again, the idea is to find potential errors before they happen. Along with quality products, U.S. businesses are serious about providing top customer service. But even though physical goods can be designed and manufactured to near perfection, there is no similar process that can be applied to services. For instance, a jeweler can develop a method of making gold rings that ensures a flawless end product every time. However, there is no such guarantee of quality when designing and providing a service experience like a dance lesson or a cab ride through New York City. In those instances, it's hard to predict how some customers will react to even the most professional service providers. Page 239. The Baldrige Awards. A standard was set for overall company quality with the introduction of the Malcolm Baldrige National Quality Awards, named in honor of a former U.S. Secretary of Commerce. Companies can apply for these awards in each of the following areas: manufacturing services, small businesses, nonprofit, and government, education, and healthcare. To qualify, an organization has to show quality in key areas such as leadership, strategic planning, customer and market focus, information and analysis, human resource focus, process management, and business results. Major criteria for earning the award include whether customer wants and needs are being met and whether customer satisfaction ratings are better than those of competitors. As you can see, the focus is shifting away from just making quality goods and services to providing top quality customer service in all respects. ISO 9001 and ISO 14001 standards. The International Organization for Standardization, ISO, is a worldwide federation of national standards bodies from more than 170 countries that set global measures for the quality of individual products. ISO is a non-governmental organization established to promote the development of world standards, to facilitate the international exchange of goods and services. ISO is not an acronym. It comes from the Greek word ISOS, meaning oneness. ISO 9001 is the common name given to quality management and assurance standards. These standards require that a company determine what customer needs are, including regulatory and legal requirements, and make communication arrangements to handle issues such as complaints. Other standards cover process control, product testing, storage, and delivery. What makes ISO 9001 so important is that the European Union, EU, demands that companies that want to do business with the EU be certified by ISO standards. Some major U.S. companies are also demanding that suppliers meet these standards. Several accreditation agencies in Europe and the United States will certify that a company meets these standards for all phases of its operations, from product development through production and testing to installation. ISO 14001 is a collection of the best practices for managing an organization's impact on the environment. As an environmental management system, it does not prescribe a performance level. Requirements for certification include having an environmental policy, having specific improvement targets, conducting audits of environmental programs, and maintaining top management review of the processes. Certification in both ISO 9001 and ISO 14001 would show that a firm has a world-class management system in both quality and environmental standards. In the past, firms assigned employees separately to meet each set of standards. Today, ISO 9001 and 14001 standards have been blended so that an organization can work on both at once. ISO has also compiled social responsibility guidelines to go with other standards. Test prep. What are the major criteria for facility location? What is the difference between MRP and ERP? What is just-in-time inventory control? What are Six Sigma Quality and Baldrige Award, ISO 9001 and ISO 14001? Page 240. Control procedures, PERT, and Gantt charts, LO 9-5. Explain the use of PERT and Gantt charts to control manufacturing processes. Operations managers must ensure products are manufactured and delivered on time, on budget, and to specifications. And to specifications. How can managers be sure all will go smoothly and be completed by the required time? One popular technique for monitoring the progress of production was developed in the 1950s by the U.S. Navy for constructing nuclear submarines. The Program Evolution and Review Technique, PERT. PERT users analyze these tasks to complete a given project, estimate the time needed to complete each task, and compute the minimum time needed to complete the whole project. The steps used in PERT are 1. Analyzing and sequencing tasks that need to be done. 2. Estimating the time needed to complete each task. 3. Drawing a PERT network illustrating the information from steps 1 and 2. And 4. Identifying the critical path. The critical path is the sequence of tasks that takes the longest time to complete. We use the word critical because a delay anywhere along this path will cause the project or production run to be late. Figure 9.3 illustrates a PERT chart for producing a music video. The boxes indicate completed tasks, and the arrows indicate the time needed to complete each. The path from one completed task to another illustrates the relationships among tasks. The arrow from set design to set materials purchased indicates we must design the set before we can purchase the materials. The critical path indicated by the bold black arrows shows producing the set takes more time than auditioning dancers, choreographing dances, or designing and making costumes. The project manager now knows it's critical that set construction remain on schedule if the project is to be completed on time, but short delays in dance and costume preparation are unlikely to delay it. Figure 9.3 PERT chart for a music video. The minimum amount of time it will take to produce this video is 15 weeks. To get that number, you add the 1 week it takes to pick a star and a song to the 4 weeks to set a design, the 2 weeks to purchase set materials, the 6 weeks to construct the set, the 1 week of rehearsals, and the final 1 week when the video is made. That's the critical path. Any delay in that process will delay the final video. Start. 1 week, star and song chosen. 4 weeks, set designed. Set materials purchased. Set constructed. 1 week, dance rehearsed. Video filmed. Star and song chosen. Dancers selected. 2 weeks, dance choreographed. 6 weeks, dance rehearsed. Video filmed. 3 weeks, costume design. 1 week, dancers measured. 4 weeks, costumes made. A PERT network can be made up of thousands of events over many months. Today, this complex procedure is simplified by using a computer. Another, more basic strategy manufacturers use for measuring production progress is a Gantt chart. A Gantt chart, named for its developer Henry L. Gantt, is a bar graph, now also prepared by computer, that clearly shows what projects are being worked on and how much has been completed at any given time. Figure 9.4. A Gantt chart for a doll manufacturer shows that the doll's heads and bodies should be completed before the clothing is sewn. It also shows that at the end of week 3, the doll's bodies are ready, but the heads are about half a week behind. Using a Gantt-like computer program, a manager can trace the production process minute by minute to determine which tasks are on time and which are behind, so that adjustments can be made to allow the company to stay on schedule. Page 241. Figure 9.4. Gantt chart for a doll manufacturer. A Gantt chart enables a production manager to see at a glance when projects are scheduled to be completed and what the status is now. For example, the doll's heads and bodies should be completed before the clothing is sewn, but they could be a little late as long as everything is ready for assembly in week 6. This chart shows that at the end of the week 3, the doll's bodies are ready, but the heads are about a half a week behind. Machine A, heads molded. Machine B, bodies molded. Machine C, fabric cut. Machine D, clothing sewn. Line A, assembly. Line B, painting. Week 1, week 2, week 3, week 4, week 5, week 6, week 7. White equals completed work. Brown equals work to be done. McGraw-Hill Connect. I see it. Need help understanding Gantt and PERT charts? Click on the video for a brief animated explanation. Preparing for the future. The United States remains a major industrial country, but competition from countries such as China grows stronger each year. Tremendous opportunities exist for careers in operations management, as both manufacturing and service companies fight to stay competitive. Students who can see future trends and have the technological and creative skills to work in tomorrow's highly automated factories and modern service facilities will benefit. Test prep. Draw a PERT chart for making a breakfast of 3-minute eggs, buttered toast, and coffee. Define critical path. How could you use a Gantt chart to keep track of production? Summary. LO9-1. Describe the current state of U.S. manufacturing and what manufacturers have done to become more competitive. Page 242. What is the current state of manufacturing in the United States? Activity in the nation's manufacturing sector has declined since its height. The result has been fewer jobs in manufacturing, even though manufacturing companies offer fewer jobs. They have become more productive, meaning that they need fewer employees to do the same amount of work. Today, many manufacturing jobs are coming back to the United States as labor costs and supply chain problems increase in other countries. Much of this chapter is devoted to showing you what manufacturers and service providers can do to revive and reinforce the U.S. economy to continue as world-class competitors. What have U.S. manufacturers done to achieve increased output? U.S. manufacturers have increased output by emphasizing close relationships with suppliers and other companies to satisfy customer needs, continuous improvement, quality, site selection, use of the internet to unite companies, and production techniques such as enterprise resource planning, computer integrated manufacturing, flexible manufacturing, lean manufacturing, robotics, and 3D printing. LO9-2. Describe the evolution from production to operations management. What is production management? Production management consists of all the activities managers do to help their firms create goods. To reflect the change in importance from manufacturing to services, the term production is often replaced by the term operations. What is operations management? Operations management is the specialized area in management that converts or transforms resources, including human resources, into goods and services. What kind of firms use operations managers? Firms in both the manufacturing and service sectors use operations managers. LO9-3. Identify various production processes and describe techniques that improve productivity, including computer-aided design and manufacturing, flexible manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. What is process manufacturing and how does it differ from assembly processes? Process manufacturing physically or chemically changes materials. Assembly processes put together components and finished products such as automobiles. How do CAD and CAM systems work? Design changes made in computer-aided design, CAD, are instantly incorporated into the computer-aided manufacturing, CAM, process. The linking of CAD and CAM is computer-integrated manufacturing, CIM. What is flexible manufacturing? Flexible manufacturing means designing machines to produce a variety of products. What is lean manufacturing? Lean manufacturing is the production of goods using less of everything than in mass production. Less human effort, less manufacturing space, less investment in tools, and less engineering time to develop a new product. What is mass customization? Mass customization means making customer design. Mass customization means making custom designed goods and services for a large number of individual customers. Flexible manufacturing makes mass customization possible. Given the exact needs of a customer, flexible machines can produce a customized good as fast as mass-produced goods were once made. Mass customization is also important in service industries. How do robotics help make manufacturers more competitive? Industrial robots can work 24 hours a day, 7 days a week with great precision. Many of the jobs they replace are repetitive, are dangerous, or require precision for which robotics are necessary, or at least helpful to make workers more productive. Workers and robotics, called collaborative robots or cobots, are working together more frequently in today's manufacturing environment. Robots are also beginning to encroach on white-collar jobs in many professions. What is 3D printing and what is 3D printing and what is it used for? 3D printing, also known as additive manufacturing, is technology that creates a product one layer at a time by a nozzle similar to those found in inkjet printers. 3D printing is largely used to create prototype models or molds for other industrial projects, but use is growing significantly and today is involved in areas such as medical equipment, orthopedic implants, airplane components, and even bridges and houses. Page 243, LO 9-4. Describe operations management planning issues including facility location, facility layout, materials, requirement planning, purchasing, just-in-time inventory control, and quality control. What is facility location and how does it differ from facility layout? Facility location is the process of selecting a geographic location for a company's operations. Facility layout is the physical arrangement of resources, including people, to produce goods and services effectively and efficiently. How do managers evaluate different sites? Labor costs and land costs are two major criteria for selecting the right sites. Labor costs and land costs are two major criteria for selecting the right sites. Other criteria include whether resources are plentiful and inexpensive, skilled workers are available or are trained, crime rates are low, taxes are low, and the local government offers support, energy and water are available, transportation costs are low, and the quantity of life and quantity of education are high. What relationship do materials requirement planning, MRP, and enterprise resource planning, ERP, have with the production process? MRP is a computer-based operations management system that uses sales forecasts to make sure the needed parts and materials are available at the right time and place. Enterprise Resource Planning, ERP, a newer version of MRP, combines the computerized functions of all the divisions and subsidiaries of the firm, such as finance, material requirements, planning, human resources, and order fulfillment, into a single integrated software program that uses a single database. The result is shorter time between orders and payment, less staff to do ordering and order processing, reduced inventories, and better customer service for all the firms involved. What is just-in-time JIT inventory control? JIT requires suppliers to deliver parts and materials just in time to go on the assembly line, so they don't have to be stored at the firm's location or in warehouses at a high cost. What is Six Sigma quality, SQC and SPC? Six Sigma quality sets standards at just 3.4 defects per million opportunities and detects potential problems before they occur. Statistical quality control, SQC, is the process some managers use to continually monitor all processes in the production process and ensure quality is being built into the product from the beginning. Statistical process control, SPC, tests statistical samples of product components at each stage of the production process and plots the results on a graph so managers can recognize and correct deviations from quality standards. What quality standards do firms use in the United States? To qualify for the Malcolm Baldrige National Quality Award, a company must demonstrate quality in 7 key areas: leadership, strategic planning, customer and market focus, information and analysis, human resource focus, process management, and business results. International standards U.S. firms strive to meet include International standards U.S. firms strive to meet include ISO 9001 and ISO 14001. The first is a world standard for quality, and the second is a collection of the best practices for managing an organization's impact on the environment. LO 9-5. Explain the use of PERT and Gantt charts to control manufacturing processes. Is there any relationship between a PERT chart and a Gantt chart? Figure 9.3 shows a PERT chart. Figure 9.4 shows a Gantt chart. Whereas PERT is a tool used for planning, a Gantt chart is a tool used to measure progress. Page 244. Key terms: assembly process, computer-aided design, CAD, computer-aided manufacturing, CAM, computer-integrated manufacturing, CIM, continuous process, critical path, enterprise resource planning, ERP, facility layout, facility location, flexible manufacturing, form utility, Gantt chart, intermittent process, ISO 9001, ISO 14001, just-in-time JIT inventory control, lean manufacturing, mass customization, materials requirement planning, MRP, operations management, process manufacturing, production management, program evaluation, and review technique, PERT, purchasing quality, Six Sigma quality, statistical process control, SPC, statistical quality control, SQC, telecommuting. Critical thinking. Critical thinking. 1. Workers on the manufacturing floor are being replaced by robots, or workers on the manufacturing floor are being replaced by robots or work side by side with them and other machines. On the one hand, this lets companies compete with lower cost labor from other countries. On the other hand, automation does eliminate many jobs. Are you concerned that automation may increase unemployment or underemployment in the United States and around the world? Why or why not? 2. Computer Integrated Manufacturing, CIM, has revolutionized the production process. What have such changes meant for the clothing industry, the shoe industry, and other fashion-related industries? What will they mean for other consumer and industrial goods industries? How will you benefit as a consumer? One way to create new jobs in the United States is to increase innovation among new graduates from engineering and sciences. How can the United States motivate more students to major in those areas? Putting principles to work. Purpose: to illustrate production processes. Exercise: go to youtube.com and search for the video How It's Made. McDonald's Chicken McNuggets. How it's made official. You'll see how Tyson makes chicken nuggets for McDonald's. 1. Does Tyson use process manufacturing or the assembly process? Is the production of McDonald's McNuggets an intermittent or continuous production process? Justify your answers. What location factors might go into the selection of a manufacturing site for McDonald's McNuggets? Page 245. Developer career skills. Key: team, analytic, communication, technology. 1. Choosing the right location for a manufacturing plant or a service organization is often critical to its success. Choosing the right location for a manufacturing plant or a service organization is often critical to its success. Form small groups and have each group member pick one manufacturing plant or one service organization in your town and list at least 3 reasons why its location helps or hinders its success. If its location is not ideal, what would be a better one? 2. In teams of 4 or 5, discuss the need for better operations management in the airline industry. Have the team develop a report listing A. Problems team members have encountered in traveling by air. B. Suggestions for improving operations so such problems won't occur in the future. And C. Ideas for handling growing misbehavior of passengers on flights. 3. Discuss some of the advantages and disadvantages of producing goods overseas using inexpensive labor. Summarize the moral aspects, health risks, and ethical dimensions of this practice. 4. Think of any production facility at your school, such as a sandwich shop, library, or copy center, and redesign the layout. Make a pencil sketch to more effectively serve customers, students, and allow employees to be more effective and efficient. Think about recent experiences you have had with service organizations and select one in which you had to wait for an unreasonable length of time to get what you wanted. Describe what happens when customers are inconvenienced and explain how management could make the operation more efficient and customer-oriented. Career exploration. If you are interested in pursuing a career in production, here are a few to consider. Find out about the tasks performed, skills needed, pay, and opportunity outlook in these fields. in the Occupational Outlook Handbook, OOH, at BLS.gov. Production planning and expediting clerk coordinates and expedites the flow of work and materials within or between departments according to the production schedule. First line supervisor directly supervises and coordinates the activities of production and operating workers, such as inspectors, precision workers, machine setters, and operators, assemblers, fabricators, and plant and system operators. Industrial production manager oversees the daily operations of manufacturing and related plants, coordinates plans and directs the activities used to create a wide range of goods such as cars, computer equipment, or paper products. Producer and director creates motion pictures, television shows, live theater, commercials, and other performing arts productions. Video Case 1, McGraw-Hill Connect, Production in the 21st Century. We sometimes read or hear about the downfall of U.S. manufacturing and how many people are losing their jobs in manufacturing. It sounds depressing, but the question is, has the United States really fallen that far behind other countries in manufacturing capability? The answer is no. This video highlights how production processes have changed and making production and operations more efficient through innovative operations management. Every product we buy has been created and distributed through a series of processes that transforms raw materials, machinery, and labor into goods and services. Operations management is a specialized area of management that focuses on designing, supervising, and improving the transformation process, as well as keeping costs to a minimum. Operations management is responsible for purchasing parts, overseeing suppliers, scheduling production, maintaining inventory and quality control, and performing other duties. Operations management is a key part of service businesses as well, as companies seek to provide great customer service while keeping costs to a minimum. Originally, goods were mass-produced with little input from customers. As Henry Ford once said, "You can have any color Ford you want, so long as it's black." How things have changed. Today, Ford Motor Company encourages its customers to choose their colors online instead of having to settle for what a dealer has on the lot. While such customization costs more than Henry Ford's one-color strategy, customization is crucial for U.S. producers so they can compete in an expanding global economy. Advances in technology have also given a huge boost to customization and efficiency. Computer-aided design, CAD, which uses precise drawings of a product in both 2D and 3D, coupled with computer-aided manufacturing, CAM, makes it possible to customize even the smallest orders. CAD and CAM also allows manufacturers to make small changes quickly without having to completely redo a production process. Through flexible manufacturing, companies can design machinery that can produce multiple product variations at any time. For example, M&M's can create its candies with the same familiar taste, size, and shape, but with multiple colors and special messages. Page 246. It's hard to deny the impact that robots have had on the product. It's hard to deny the impact that robots have had on the production process. Robotics has made manufacturing more efficient from a production and cost perspective. Today, robotics plays a major role in almost every process in production. It is also a key part of operations management planning. Operations management planning's primary objective is to make decisions regarding key issues such as the location of a production facility. Factors that influence the decision about where to locate a plant are access to resources, proximity to transportation, availability of labor, and quality of life. After location facilities have been determined, the most efficient layout of the facility must be designed. Supplies and materials sitting idle cost the company money. That's why inventory control is vital to a firm's efficiency and profitability. Many companies have turned to just-in-time inventory control systems to make sure that materials and supplies are available at the right place and time without excess storage costs. The use of enterprise resource planning, ERP, software has helped make the control process even more effective. Through ERP, companies can automatically route an order to scheduling, then production, and on to shipping and billing. All production and operation strategies are put in place to enhance overall product quality. Therefore, quality control is the final and perhaps most important operations management process. If a company does not produce a quality product, it will fail. Traditionally, quality control was conducted after the production of goods. If the goods were found to be deficient, the products were scrapped, often at a high cost. Today, companies conduct quality control testing throughout the production process, so errors can be identified and corrected immediately to prevent having to be discarded at the end. The next time you take a cold drink from a can, take a ride on a bike, or read a good book, think about the U.S. companies that make those goods. Think, too, of the opportunities available to tomorrow's college graduates. Often students are not attracted to the manufacturing sector, even though many opportunities exist. Think of companies producing emerging products such as solar panels, lithium-ion batteries, and more. You only have to look around your home, school, or office to see the many products being made today and the many products that will be made in the future using biotechnology, nanotechnology, and so on. Thinking it over. 1. Looking at the future of manufacturing in the United States, do you think U.S. companies are adapting to the challenges of global manufacturing? 2. Why has just-in-time inventory control become a dominant production process used in the automobile industry? Can you name other industries? Where it would be effective? Could supply chain problems affect just-in-time processes? 3. Why is it important to apply quality control processes throughout production rather than evaluate products only at the end of the production cycle? Video case 2. McGraw-Hill Connect, transforming production at Nissan. Technological advancements, like automation, have greatly changed manufacturing over the past 2 decades, with factory robots becoming more important than ever before. In fact, manufacturers' increasing reliance on automation has led some to speculate that robotic labor will eventually replace human workers. At Nissan, however, nothing could be further from the truth. The Japanese automaker uses technology to enhance the work of employees, creating a cutting-edge business environment where vast automated resources are guided by human creativity. Efficiency and productivity are Nissan's core goals, and motivated workers are needed to achieve these objectives. That's why the company relies on automation to free employees from mundane, monotonous tasks that sometimes result in product mistakes and employee dissatisfaction. Instead, Nissan harnesses the creative potential of its staff so that they can work alongside automated systems that drive the company's capacity for innovation. Automation is the use of robots in order to reduce the human effort that is required to complete a task. Nissan closely studies its production processes and determines which specific tasks can be automated. Simple, repetitive, and physically demanding jobs are the most common candidates for automation. For example, Nissan workers had long struggled with the installation of an automobile's headliner. Nissan workers had long struggled with the installation of an automobile's headliner, a challenging task that the company soon automated. Changing this process helped reduce workers' physical strain while also improving efficiency. Of course, Nissan is not fully automating every task in the assembly process. Instead, the company strives to make work synergistic by embracing cobots, which is short for collaborative robots. Cobots are robotic arms that employees use to complete monotonous or exhausting tasks, partners that literally lighten the workload for humans. Cobots are very agile, safe to work with, and able to take over many unwanted tasks. Since they are programmable and movable, their movements can be easily customized. Page 247. Nissan doesn't limit advanced technology to the production floor. The company also employs artificial intelligence (AI) to improve product quality control. The company's inspection scanner evaluates car parts to a very high degree of accuracy, providing workers with a sense of assurance that allows them to focus on other tasks. Nissan's ultimate goal is to integrate, not replace, human labor with robots, cobots, and AI. Rather than taking over the operation entirely, advanced technology will instead work side by side with humans in order to make Nissan as efficient and productive as possible. Thinking it over. 1. What are the advantages and disadvantages of human labor in automotive production? 2. Why is Nissan determined to integrate automated capabilities with its human employees? 3. How could other industries besides the automotive sector utilize robots, cobots, and AI? Can you offer some examples? Page 248. Notes. 1. American Identity of Economic Success. U.S. Bureau of Labor Statistics, BLS.gov, accessed April 2022. 2. Western Manufacturing Employment Trends and Peaks over 30 Years. U.S. Bureau of Labor Statistics, BLS.gov, January 2022. All employees, manufacturing, Federal Reserve Bank of St. Louis, FRED dot St. Louis FED.org, accessed February 2022. 3. Number of employees in the United States in January 2023. By industry, Statista.com, February 2023. All employees, manufacturing, Federal Reserve Bank of St. Louis, FRED.St. Louis, FED.org, accessed February 2023. 4. Dave Evans, top 3 predictions for the manufacturing industry in 2023. Forbes, Forbes.com, December 6, 2022. Brooke Sutherland, what recession? Manufacturers still plan to spend big. The Washington Post, WashingtonPost.com, February 1st, 2023. Yuka Hayashi, Biden administration's big manufacturing push could transform global trade. The Wall Street Journal, WSJ.com, January 12, 2023. Part 4, Management of Human Resources, Motivating Employees to Produce Quality Goods and Services. Chapter 10, Motivating Employees, page 249.